In this lecture, we're going to talk about a type of a cell that is called galvanic cell. Another name of galvanic cell is called voltaic cell. It is a type of electrochemical cell. We know that in all of the cells, the chemical energy transfers into the electrical energy, where the process used is called redox reaction. Talk about redox reaction is combination of reduction and oxidation. Reduction means gain of electron, where oxidation means loss of electron. You can also learn these terms by the abbreviation that is GER, gain of electron, that is called reduction, and LEO, LEO, loss of electron, is called oxidation. If we move on to the process of galvanic cell or the formation of galvanic cell, it is basically consists of two beakers. Now, these two beakers can be of any material, but most priority is given to the glass material or the metals. In these beakers, or we can call it as in these containers, there is 1 molar concentration of the zinc SO4, that is probably the electrolyte. Here we have used copper SO4, that probably is the copper electrolyte. Here, one thing to be noted is that whenever we use the galvanic cell, the reaction is only possible wherever there is the strong electrolyte being used. Here, one thing more is that these two electrocontainers are connected by first, these containers consist of a rod. Here, in the zinc solution, we do have rod of zinc, while in the copper solution, we do have rod of copper. These solutions rod are connected by a wire. But here, one thing to be noted is that I said that this galvanic cell offers the spontaneous solution. But here we know that whenever there is the oxidation, that probably means that that cell is being used, or that side is being used as the anode. But in the electrolytic cell or electrochemical cell, the oxidation stands for the cathode. Now, here the loss of the electrons are done by the zinc. That's why this terminal is termed as anode, while this term is termed as the cathode. Now, what we're going to do is that to measure how many cell potential does this cell creates, we will place a voltmeter. By help of this voltmeter, we can actually indicate from where the electrons are moving. That probably means if electrons move in the direction of this, so it will arrow like this. If the electrons are moving in this direction, it will make the arrow like this. that to start the reaction, we have to put an external thing that is known as the salt bridge. Salt bridge is basically a U-shaped glass in which an inert electrolyte is filled along with gel, or that electrolyte is own self is a gel. It allows the flows of ions but prevent mixing the solution. Each of the U-shaped ending is covered by a cotton pad which prevents the solution to mix in the electrolyte. Now here, this half cell cannot do anything. Half cell is basically the half of the galvanic cell. That probably means if I talk about this area, one of the rod and a container is termed as the half cell, while this full container is known as the full cell or the normal cell. Now, how this is going to happen? When in a simple solution we add the salt bridge, this actually creates a violence in the solutions. Now in results, the electrons will start sticking to the zinc rod, and this zinc rod will start moving its electron in the wire. Now these electrons will move in the direction towards the copper rod. The electrons in the copper rod will be stick. Now this will cause the N in the galvanic cell, that is also known as that this cell is now expired. This is how this happens. Whenever the construction is completed and the galvanic cell is optional, the voltmeter shows the EMF of the cell, which can be in the form of the points. Now, note the flow of the electrons in the external circuit, that is this wire. It should be from zinc electrode towards the copper electrode. Thus, the electrons must have originated as zinc, and zinc is a node where oxidation takes place. After completing this whole section, we will learn about the electrochemical series, by which we can actually tell that how many electrons are catched by this and transferred here. How much electricity can be produced. Thank you so much for watching this video.